Hello again, folks. Welcome to another exciting episode of Quick and Dirty Java. Last recording that I made was the introduction to control statements or control structures in Java. So that was the part one to this. This is part two. If you'll recall, in part one, we discussed the three categories of control statements, and we also talked about what is the flow of control. So the control statements control the flow of execution. And it basically decides how do we line the written instructions up with the order in which they're executed. So if we skip around or skip over something or choose between or among different options, then we called that selection control. If we had a situation where each executed statement is executed exactly in the order that it was written and there's no bouncing around or jumping around or anything within a single method, then that's sequential. That's the default. So we talked about sequential and selection. Now the third category, so there's sequential, selection. The third category is repetition control statements. So these are also known as iteration or iterative control statements or control structures. And colloquially and probably for the most part, if you're just discussing in a group, you'll usually hear people just say loops. Okay, loops. So those are the three major categories. We also talked about the relational operators previously and the logic operators. Okay, so make sure that you are becoming familiar with those. If you aren't familiar with them, make sure that you review the control structures part one. So this week again we're discussing repetition control statements. So I'm going to create a new Java class. This Java class, we'll call it Loopy Fun. Delete all the extra comments here. Okay, so the first thing we're going to do is we're going to introduce, we're going to talk about some of the loop types. So repetition, the different statements that are available are the while loop, the do while loop, and the for loop. So the while loop is the one we usually start with. It's when we want something to repeat over and over again, we use a repetition control statement, and that's what computers are very, very good at. They're good at performing redundant tasks over and over again. And as we saw last time, they're good at making decisions and choosing a particular branch of code to execute based on a set of circumstances. Well, we're going to use these circumstances or conditions to control whether or not we repeat something. So in this case, I'm going to create a counter. Okay, I'll call it count, just count. And then I'll say while the count is less than 10, I want to loop and print out count equals, and then just print out the count. So it's going to be very simple. Now one thing I need to make sure that I do inside this loop, remember this is equal to count equals count plus 1. Or count plus equals 1, but since increment is done so frequently, it gets its own operator. Usually we use the post increment operator, but you can use the prefix increment operator as well. So it doesn't really matter. If it's on its own line, it really doesn't matter. So let's think about what this should do. Unlike the selection control statements, which will evaluate the statement, and then if it's true, it'll do it once, and then if it's false, it'll skip over it. The repetition control statements are a little bit different. What they're going to do is they're going to evaluate it, perform the action, update the counter variable usually in this case, and then go back up to the top where the construct begins and reevaluate. So that's why we have to increment the counter. If we don't, this loop's going to go on and on and on forever, theoretically at least. Eventually the operating system or the JVM is going to say, wait a minute, you can't do that anymore. And just it'll, kill the process or tell us that it's frozen. But theoretically we would create what's called an infinite loop. So that is considered a logic error. You want to make sure if you're using a counter-controlled loop that you make sure you're updating the counter and moving it towards this statement being false eventually. So while it's true, it will continue looping. But you'll notice I start at 0, I'm counting up to, well, 1 less than 10, since we're dealing with integers. I'm saying strictly less than, not less than or equal to. So it's going to count up to 9, and then when it counts to 10, it'll reevaluate it and say 10 less than 10, that's false. So then it will go and start executing down here, and then we can say done. So let's see what we have printed out when we run this. As we anticipated, it says count equals 0 the first iteration through the loop. The counter gets updated in memory and then goes up to the top again. And then since it was updated by 1, the counter is now 1. Is 1 less than 10? Yes. So print out count equals 1. So it prints out the second line here with count equals 1. Then it updates to count equals 2. Prints out count equals 2, etc., all the way until we get to 9. Now what happens at 9? I just explained it, but I'll re-explain it in context. When it says 9 less than 10, that's true. Prints out the count equals 9, and it does increment it to 10. But then what does it do? It goes up to the top and then asks the question, is 10 less than 10? 10 is not less than 10. That's false. So it will skip over the remainder or the body of the loop on that iteration, and it will go here. So it'll continue on its merry way, sequentially as it was before. So this is a classic example of what we call a counter-controlled or count-controlled repetition. Okay, or counter-controlled loop, because it's controlled by a specific value used as a counter. The while loop is sometimes used for that. One of its cousins, another type, which we're going to create in default package again, we'll call this loopy fun do while. Okay, so inside here, it's about the same thing. Okay, the only difference is that, let's say the count is 0, and then I say do, and eventually down here I'm going to say while the count is less than 10 or something like that. I'm going to print out count is as before, and then count plus plus. Let's see if we can discern anything different about this. I also didn't put a. I'll put a done down here so it's consistent. So you notice that it prints the exact same thing that the while loop did. So you might wonder, well, what's the difference? Well, the while loop that we saw earlier, this one is pre-test loop. Tests the condition before executing the body. Okay, so it may never even run if the statement is false going in. So if the count is 10, if I set the count to 10 right here, now remember this is the while loop version, not the do while that we just did. If I set the count to 10 and then run loopy fun, you'll notice it just prints out done because that's outside the loop. It never enters the body of the loop. That's because it does the test initially, finds that it's false, and skips over the entire body, never even executes it because it's false going in. I'm going to restore it to 0 and then go back to my friend loopy fun do while. Now this one, if I make this 10 this time, so that would make the condition false, right? If I run this one now, you'll notice that it does in fact execute once. It will print out this counter. It will increment it, so technically it's testing 11 less than 10 in this case. So this is actually a special type of loop called a pre-test loop. Okay, do whatever is in the block of code and then perform the test for loop continuation. Okay, so just so we get some terminology down, in both of these situations, this test count less than 10 is called the loop continuation condition. Okay, so I'm going to copy that and put that over here as well. So we have both of these. So the count less than 10 is called the loop continuation condition. That determines whether the loop continues or not. If it's ever false, it will not continue. So the difference we see here is that the do while loop is guaranteed to run or to execute its body at least once, whereas the while loop is not guaranteed to do that. Okay, so it is a pre-test loop for the do while loop. The while loop is post-test, the do while loop is pre-test. Our third type of loop is called the for loop. So we'll say loopy fun for, okay. And inside here, I create the main method again. And for this one, this is kind of an awkward looking one if you're used to the while and the do while, but this is actually very, very handy. This one's actually perfect for these counter controlled or count controlled loops that we've been looking at thus far, because everything is in the header of the loop. Instead of just having to declare a counter outside the loop, you can actually declare it and update it inside the header of the loop. So usually with a for loop, we don't say count, although it does not matter as long as it's a valid variable name, a valid identifier. We usually start for loops with I. We use letters like I, J, K, X, Y, Z sometimes, or A, B, C. But usually I, J, and K are the most common. So if I have for int I equals 0, I less than 10, I plus plus. So what happens here is this is only performed once when it first enters the loop, and then this condition is checked every time an iteration occurs, and then this happens at the end of a particular iteration, so it updates. So let's see what we get here. We'll see the count is I, or actually I'll just say I is I, because we are using a different variable name. And then of course I'll put done down here. Let's see what happens now. Pretty much what you expect. Goes counts all the way from 0 all the way up to 9. And then terminates. So this is perfect for counter-controlled repetition. Perfect for counter-controlled repetition. Now, the other question you might be having, since we've gone over all these loops with these counters, is I keep talking about counter-controlled repetition, so is there another kind? And the answer is yes, because you don't always know how many items need to be processed. So in this case, we're basically hard coding it or writing the actual number or what have you, or we could even take a variable in, but by the time it runs, it knows how many iterations it needs to go over. There's another kind, which we'll talk about here. This is called, we'll call it loopy Sentinel. Now this does not require us to learn a different construct really. We're still going to use one of the three while, do while, or for loops. Those are the three that we have at our disposal. But we're going to use them in a slightly different way. Now I'm not going to use the for loop because the for loop, it's not usually, it looks kind of awkward and isn't really good for this type of Sentinel controlled repetition. So Sentinel controlled repetition, okay, requires a special value to terminate rather than using a counter. Okay, so we're not counting a specific number of times to control the loop. We're looking for a specific value. So I could say something like this. I'll say int, we'll say int value is 0, and then I'll say, I could tell the user enter an integer to be accumulated, and we might also have a sum here. Maybe we're going to sum up a bunch of numbers. And we could also put another statement that says or, okay, I'll say enter a positive integer. This is probably an easy example. Or enter a negative integer to quit. Okay, so a negative integer would be a Sentinel value or a Sentinel set of Sentinel values to tell it we want to be done with it. Okay, so while loops and do while loops are better with the Sentinel values, although you can use them with count control. They're not super awkward. They're not as good as the for loop. But for Sentinel control, they're definitely better than for loops. Okay, so we want to definitely use while and do while for these. So what I'm going to say is I'm going to say while the value that the person enters is greater than or equal to 0. Okay, so it's kind of implied here. So Sentinel values are any negative number. So that will cause this to terminate. Now I do have to get information from the user. So if you're not familiar with this, this might look a little bit squirrely to you. But it's really not super difficult. To get information from the user from the keyboard, I have to use something called the scanner. The scanner is not immediately available like the primitives or the string data type or anything like that, or the system class here, the out object. You have to import this extra package, java.util.scanner. That's so that that's the easiest way to do it, and it'll help us recognize the scanner. So I'm going to create scanner keyboard. If you don't know how it's working, just use this verbatim and you won't have a problem. Okay, so I've got scanner keyboard equals new scanner system.in. And briefly, although this isn't a lecture on the I/O, file I/O, or rather user input, user I/O, what this is doing is this is creating a variable whose identifier is keyboard. Its type is a scanner reference, and we are using the new keyword, which is used frequently most of the time with anything that's not a primitive. You remember what we talked about, the 8 primitives in the earlier lesson? There are 8 primitives: byte, short, int, long, float, double, char, boolean. If it's not a primitive, it's a reference type. So this is a reference type. Scanner's a reference type, so it holds the memory address of this new scanner object, and as a parameter, or an argument rather, we pass in system.in, which is called the standard input object. Now that should look kind of familiar because we've got system.out right here. System.out allows us to send data to the console, and then system.in allows us to get information in from that is typed into the console, usually through the keyboard. So system.out is the standard output object. System.in is the standard input object. So we're preparing this keyboard to take input from the user, and we just prompted the user. So this is called a prompt. Okay, so we say enter positive integer to be accumulated, or enter a negative integer to quit. So I'm going to say the value is equal to, and then you use the keyboard. Next, int. Okay, so I get that value. That's kind of a priming read. As soon as it goes in here, I'm going to say sum plus equals the value that was entered in. That's the same as sum equals plus value. And then what I want to do is, I'm not using a counter. What I'm really going to need to do is just kind of prompt the user again. So inside the loop, I have this. Now, for a lot of people, this might look kind of, especially if you're maybe a seasoned developer or whatever, some of you might be thinking, wow, that's kind of, you've got repeated code here. But if you're a real seasoned developer, you know this is called a priming read. Okay, it's considered acceptable to have this duplication because it prepares the loop. So it primes the loop. It gets in here, sums the value, and then as long as the value that was entered was not negative, it will add it to the sum and keep going. So let's see what we have here. At the end, I'm going to say sum equals, and then we're just going to print out the sum. So I think I've got it all right, but there might be an error. I'm kind of doing this on the fly, so we will see if there's a problem, and if there is, we'll try to fix it. So I'm going to enter 10, okay, and it asks me again, enter a positive integer, 15, 20, and 25. Then I'm going to put a -1 to tell it I want to quit. So it quits and tells me that the sum is 70. Let's see if that's right. 10 plus 15 is 25, and then plus this other 25 is 50, plus this 20 is 70. And it does indeed give us the correct value. If I run, oops, I ran debug. It doesn't really matter though. If I put -1 to start off, it's just going to tell me that the sum is 0. So if I try it again, 100, 150, 257, 363, 450, 540, 222, and then -5, it will break out finally and then tell me what the sum is of those values that I just entered. So that's a Sentinel value versus the counter-controlled repetition. So let's think again about how do we classify loops, repetition control statements. You can classify them by pre or post test, okay, or you could classify them, and you can classify them by counter versus Sentinel, also called flag control repetition. So these are just different ways that we can describe what's going on with these different mechanisms. So again, what I want you to do this time is go back and really review this material. Make sure that you're comfortable with the while loop, do while, and for loop. And for those of you wondering why I haven't discussed the range-based for yet, I don't consider it a fourth construct. It's really what I would consider syntactic sugar version of the regular for loop. If you have no idea what I'm talking about, don't worry about it. But the we'll talk about the range-based for or enhanced for loop, or what some people would call the for each loop. In fact, the actual syntax for each is used in some languages as well. But that won't really make any sense until we start talking about arrays and collections. So if you're chomping at the bit to learn about that, don't worry, we'll get around to it eventually. But for right now, just memorize the different constructs that we have, the Sentinel controlled loop, and then the counter controlled loops, and that those are all repetition control statements, also known as iteration control statements, also known as loops. So that's one of the three categories, repetition control. The three categories, again, review it: sequential control, selection control, repetition control. Okay, so that's all I have for you this time. We will enhance our understanding as we move along, and good luck on your journey. Keep studying.